Hi guys, Lee here. I'm sat in my shop on a Saturday afternoon. I've got a 3.2 VR6 with a lovely billet cover on it. I'm also sat here with a Faro Arm, which is a bit of a fancy bit of metrology equipment. And what the plan is, I'm going to sit down with you. I'm going to get the equipment out. I'm going to show you how to reverse engineer an intake flange for this. So this piece of equipment will allow me to measure this in a 3D space. So I'll be able to get the bolt pattern, I'll be able to get all the port sizes, things like that, and then I'll show you how I collect that raw data using the arm. I take it onto my laptop. We'll do some screen captures going from raw data to a final model part, 3D model part that you could either send for 3D printing, which is something we might do for test fitment. From there I'll be able to take it into my CAM package, and then using the bridge port behind me we'll make some billet inlets. As always, a 2-minute job of mounting that to a billet so that I had a nice stable base turned into a bit more drawn out affair. We are now ready to go and start measuring, but first I'll give you a bit of a talk through of what a gauge actually is, a Faro Arm gauge. This is it really. It's a bunch of servos, there, and there. So it's 6 servos connected to a point which is calibrated from each point, and then it gives you that measurement in the 3D space. These are Swiss made, as you can see, very accurate. A lot of people try and slag them off, but it really is depending on how you use them. But these can get down to a tolerance of 0.025, which is a thousandth of an inch, which for bolt holes and what we're doing is plenty good. This is the same way that I digitised the VR6 cover, taking all the mounting points and the basic rough shape of where everything is, and then it's a sit down job for a lot longer than what it does to measure it. So from this point here I'm going to do a bit of a time lapse going through some of the measuring process, just going to video me measuring it, and then I'm going to take you over to the laptop which it's connected to, and we'll do some screen grabs of that, and I'll show you what it gives you as the raw data, so then you can see what I've got to to work with when I'm taking into the CAD program. Let's get to it. As you can probably see, we're running a real high budget setup over here on the floor. What we've got to do first is you've got to warm the arm. I say warm it up, you've just got to take it through its full range of motion so that it understands what's moving and what's not moving. It's quite simple. We'll take it through the warm-up procedure. I do apologise for the camera footage and the lighting. It's less than ideal, but we're working with what we've got. So moving in, we're working with some software here that comes with the arm. I'm going to try and show you how it works in the three-dimensional space, which is going to be hard for me to show you, I'll be honest. Boom, there you go, this is what we want. Now I'm really hoping that you can see this on screen, which I bet you can't, so I'm going to take you in. See there, you got your digits moving. If we come out further, if we move it around, move the probe, all the digits on the screen move. So when you take it over to the engine over there, so you've got your hole in there, you can probe that one. And so you come back, it'll do all your thing over there, which is really good. Put that back down, I'll set you up over here so you can see what's going on. And I'm going to go straight into it. We're going to start measuring, I'll show you some raw data, and we'll go from there. Bring you guys in again. This is basically what it brings you up with. It's not much, right? But that is just your datum setting. But then also again, if I move the arm around here, like this, you can see it move on the screen, giving you that 3D representation. So once you've got your head around the principle of it, it's dead simple. So I'm going to go through it again, get all my datum points, take it off, I'll show you the screen of what I've got to work with. So going from that there, it leaves us with, which is really hard to see, is the basic outline. The ports aren't particularly great because it's a cast surface and they're all over the place. As you can see in there, not easy to measure because they're all different. But we've got all the data we need. We've got the mounting points. That's it, basically. Let's go over to the laptop, take it into the CAD package, and go from there. Now we're over here at the laptop. This is Power Inspect. This is the raw data that we get in, and it's exactly that. It is just raw data. You don't get a lot with it. We've got some hole diameters and some center points. We've got the plane, which is the face. We've got some rectangles there, which are pretty bad. I'll end up redoing, and this is just a quick one for you guys. I'll export this now. I'll save it as an IGES file, which we can then import into my CAD package. Which is 1CNC if anyone's interested, XR7 if anyone's interested. And this is basically what I end up with and all I have to work with. I'll just delete the plane so you can see what we're working with. And that is it. So in the next couple of days, I'll take this data, I'll create a model from it, and then we can take it into, well, it's the same package, the CAM package. We can create some toolpaths for it, and we can order some billets. We can make an inlet, but this is just a basic introduction to reverse engineering and how you'd go about it. And that's it, guys. And that's the same process as I used to make this file. Which is the RS, the 07K runners. So I started off with very simple data set points. Let's create this face there. And that's all you have to really go with, guys. There's no fancy operation with 3D scanning yet. We're working with what we got. So I'll be honest, guys, I didn't give you much. We've done a bit of reverse engineering. I really don't want to call it educational, more something else. Not quite. It's an insight to what I do. I'll take you further through the process. This is just the first one that I've been able to get done and get filmed. But we are going to do another billet block. We're going to be going to do some Vauxhall stuff. So I'll take you through the full process of measuring the block, finding out what's important, the parts that have to be bob on, the parts that are just clearance and you can get away with. We'll take you through the full process of designing that one, which is just down here. That's what we'll be doing. I'm sorry for the lighting, guys. We are in a basement, so it's not perfect. And then we'll also be going through the machining process of the VW 1.8T block, which is going to be a big one for me. It's something I've wanted to do for a long time. And all the little projects in between as well. There's some bits that I'm not going to be able to show you because it's NDA and the information is kind of important. But apart from that, I'm going to show you the daily processes of what I go through. It's in a machine shop. It's like we're running on a shoestring budget. So it's not going to be anything amazing, but it'll be a daily insight into a machine shop. And we'll hopefully show you some fast cars. We'll hopefully build some of them as well. But I'm just the guy that makes the shiny stuff at the minute. Is what it is. Like and subscribe, guys, if you want to see a bit more content, because it takes a lot more than what you think just to stand there in front of a camera and show somebody something that you know how to do. It's like teaching someone to suck eggs. But you guys wanted to see a bit of it. There you go. See you next time.